Hi, everybody. My name is Dr. Chris Bird. I'm here to talk to you today about effectively communicating science. This is a presentation for the 2021 Valero Energy Foundation and Texas A&M University-Corpus Christi Virtual Coastal Bend Regional Science Fair. I'm an associate professor in the Department of Life Sciences at Texas A&M University-Corpus Christi, and I was a judge in this year's science fair. I'm going to have to turn off the video in the bottom right corner of the screen because it's going to interfere with some of the slides. So with that done, we're going to move forward with the presentation. First, I'd like to thank everybody for making this year's 2021 Science Fair a huge success, especially given that we're in the middle of a pandemic and had to make the Science Fair virtual for the first time. First, to the students, your projects were excellent and inspiring. I was very impressed by all of the projects that I had the pleasure of reviewing, and your hard work paid off and it really showed. So you should be really proud of the work that you did. To the organizers and the parents, your hard work also definitely paid off. I think that the science fair was a huge success. Like I said, especially given that it was virtual for the first time, and I'd like to thank everybody for helping to pull this off, especially the primary organizer, Dr. Deborah Plowman. Next to the judges, you serve a critical function of providing constructive criticism back to the students so that they can improve their projects. And to the students, I know that it can sometimes seem disheartening when you receive this feedback, but we're very careful to try to make it so that the feedback that you're getting is meant to help you improve the project and not just to point out little things that are wrong here and there, without pointing you in the direction of how to fix it. And lastly, to the sponsors, we want to thank you for investing in the next generation of science talent in our country and in the Coastal Bend area. Of the Valero Energy Foundation and HEB are the primary sponsors, as well as I'm sure that Texas A&M Corpus Christi, as well as Del Mar College, also has a fair amount of sponsorship and volunteering going on. So I'd like to thank everybody that were involved in this year's science fair. Now let's talk about communicating science. Now, science is a methodology that's used to generate reliable knowledge. We don't know everything about the world, and science helps us to learn and document new things that we didn't know before. Science critically is repeatable. It involves a process by which other people can repeat the experiments and confirm or deny whether the results of other experiments are valid. The proper scientific process involves documentation. This is important for the repeatability, but you don't just go out and conduct the scientific method and then not tell anybody about it. You want to write it down, you want to present it like you did here in the science fair this year. This is one of the purposes of the science fair, is to help you get used to communicating the results of your science. But there's some challenges that come along with that communicating of science. It can get technical when you're testing a hypothesis. Often it requires that you have specialization in a particular field of knowledge, which has jargon and specialized knowledge that may not be generally known to the average everyday citizen. And so this is where some problems can arise. So why is communicating science so hard? Why is it so challenging? And I crossed out science here because it's not just science that's hard. Science really, it's not that hard at all. You just follow a blueprint. It's communicating that's really the hard thing. And I think that communicating, at least for me, is the thing that's really difficult in this communicating science. And there's a few reasons why. First, breakdown and failure of communication is extremely common in everyday life. Almost every time you have a disagreement, it often doesn't stem from a true disagreement. It more often stems from a misunderstanding. Two parties often have the same views, but they may express them in different ways, and these misunderstandings lead to disagreements. That's one of the reasons why communicating is hard. So these misunderstandings that stem from poor communication lead to a breakdown of that communication further. It becomes a feedback loop where as misunderstandings accrue, communication gets poorer and poorer. Over here we have a model of this communicating science dynamic, where on one side you have the scientist and on the other side you have the audience. And maybe in the middle you have scientific communicators who are meant to dabble in both worlds of the audience as well as the scientists. Now, you don't necessarily need this. Scientists can be the communicators. I think that's one of the reasons why I was asked to speak to you today, because I am first and foremost a scientist, and I wouldn't describe myself as a scientific communicator. So on the public side, there may be some deficits in scientific literacy when it comes to a particular project of which the scientist is trying to convey. Now, this stems from the fact that nobody can be an expert in everything. And even if the audience isn't the general public, even if it's other scientists, this gap still exists. So that's why science communicators, while they serve a useful purpose, are not necessary here in this model. We could just have scientists talking directly to an audience, which may be other scientists or the public. Any way you slice it, there's a gap there that you need to cross, and it's difficult. So a scientist, the one presenting the results, has intimate knowledge of a subject that the audience doesn't have. I know that you guys who did the projects, you probably got deep into your project, and at some point you might start assuming that other people that you talk to about your project know everything that you've learned as you've gone through doing the project. But I think one of the hardest things to learn is that even for the judges, we're probably not that intimately knowledgeable about the particular subject that you're presenting on, because it's impossible for everybody to be an expert in everything. And so that's a really critical thing to realize, that you have knowledge about your project that the people you're talking to about it don't. And we have to strive to minimize these misunderstandings to maximize the communication of science. So let's start with my rule number one, and that's if you don't know the material, you can't communicate it effectively, and that goes without saying. You have to put in the work, which I know that all the projects that I had the pleasure of judging, you could tell a lot of work went into them. But if you don't do that work and you're trying to communicate science, then it's not going to work. So number one, make sure you know your material. That's step one, though. And you're not going to get to the level of a true master until you can communicate that material effectively also. It's one thing to understand it yourself. It's another thing to help somebody else understand it. And that's the way that you should think about it. Your goal here is to help the audience understand. And so this infographic is often the way that a scientific presentation goes, where the scientist is kind of streaming out facts. Let me tell you about what I did, but it's a hard transition for the audience. It's a hard pill to swallow, and you need to help to make it a little bit easier. And obviously your goals here, besides helping the audience understand, it's helping the audience understand what is it that you did, why and how did you do it, what was the result, and why does it matter. And it seems simple, but it is challenging, and it takes a good deal of effort on our parts to be effective at it. So it's very important to imagine yourself in your audience's shoes. And additionally, it's important to accurately understand the shoes that your audience is wearing. If it was hard for you to learn something, it's probably going to be hard for your audience when you're communicating what you learned. So the parts that were really hard, you're going to need to dedicate extra time to make sure that you have an effective way to communicate that. You need to try that out on other people. If you don't have the opportunity to test it out on a naive audience that hasn't heard your material at all, you have to imagine yourself being that audience. I like to imagine that I'm my mother or my sisters, and if I can explain it to them and they're not scientists, But I feel like if I can explain it to them and they'll understand, then I'll be pretty effective in explaining it to just about anybody. And this is an important point in knowing who your audience is. You should not target the most informed individual in the audience, because if you do, you won't be speaking to the majority of your audience. You want to target the least informed person in your audience. If you're able to do that, then you won't leave anybody behind. And as long as you stay true to the facts, even the most knowledgeable person in the audience won't be able to find fault with what you're presenting. Now, maybe you don't present all the nitty-gritty details, but if you stay true to the facts, that expert that's in the audience always has the opportunity to talk to you and ask you more detailed questions later. And I want to remind the students, even judges might not be familiar with the material in your project. I judged health sciences. I'm a biologist, but even the health sciences is a broad field, and it's your job to help the audience understand what it is that you did, and you need to understand who your audience is to do that. The next thing that's really important is to be able to tell a linear story. And what I have here is a picture of a person riding a roller coaster blindfolded. And if you don't tell a linear story, you don't follow the rules that I'm going to talk about here, then this is what it will be like for your audience. Now, if you know that you're going on a roller coaster and you want to ride it blindfolded, then it can be a really fun experience. But when it comes to communicating science, this is not the type of experience that you want your audience to have. So your goal is to not blindfold your audience, but the way that you do that is to give the punchline first, then show how you got there. The first way that you could do this is the primary result of your work could be in the title. And you think about it like this. If somebody looks at my presentation, looks at my poster, and they only remember one thing, what will it be? And put it right in the title. That way, if they only read the title, then at least they got that one piece of information that you wanted to convey. And if you follow this idea of putting the punchline first, then you can do that throughout your presentation. In each one of the sections, put the punchline first. On major results, describe what that result was, say above a figure, rather than saying this is a graph that's a scatter plot. Say this graph shows that y is affected by x, or when x increases, so does y. Next, it's important to be linear in the way that you're going with your story. And when you watch a movie and you're surprised at the end, that's generally a nonlinear story that's creating that surprise. Now, and again, in a movie, surprises work. In a scientific presentation, surprises are generally not good, and you probably don't want to you don't want to dabble in or delve into that into that zone. So make everything linear. Get from point A to B to C to D to E to F to G. In the same way, letting people know where you're going from place to place, this will lead to effective science communication instead of a blindfolded roller coaster ride. Next, you need to make your results bite-size. And this is something that took me till my postdoc, after my PhD, to understand. Hopefully, I'm saving you the heartache that caused me. So you want to make your results bite-sized. While this chicken here looks delicious, and in the proper context, when you had enough time to sit down and cut off the chicken and eat it, it looks good. But in the context of a scientific presentation, you don't have time to eat that whole chicken. You want chicken nuggets. So this is the way that you need to be delving out or doling out the information that you're given in small, bite-sized pieces that can be eaten on the go. So avoid excessive complexity. Use graphs instead of tables. So tables, all the numbers and data are in there, but somebody's going to have to look at that and kind of process it in their mind. And while they're looking at that table and looking at all the numbers and looking for the pattern, they can't be listening to you. So a graph that can show the result of the table in an instant is always going to be superior in a presentation format. And you want, when you show those graphs, you want the audience to be able to intuit the result when viewing the graph without thinking. Again, this goes to them listening to you instead of trying to think about the graph and figure out what's happening in that graph or that table. So there's some tips. Also realize that aesthetics matter, and aesthetics are things that are of or relating to the beautiful. It's artistic. The way that your presentation looks matters. It's not just about the content. We talked about a little bit with the figure in the last slide where I was talking about figures need to be easily interpreted. That's part of aesthetics, but also just the organization and color combinations that you use. Imagine if I used a dark blue background on this slide and you couldn't read the text. That would be a problem with the aesthetics of the slide. You want to make sure the text is readable. You want to organize and align everything. Notice throughout this presentation, while it may not be the most beautiful presentation in the world, I have a basic aesthetic that I'm adhering to throughout the whole thing, with a title in a certain place with all capitals and bolded font, and in the same font through every single one. I have an image or some sort of graphic that conveys the meaning of the slide over here, and I try to use consistent formatting. You want to organize and align your text blocks and pictures and figures and tables if you have them, but again, I suggest trying to avoid them. Be consistent, use large font sizes. One of the most common mistakes in a poster presentation is to have a tiny font size that can't be seen. And while this year was a virtual science fair, so maybe some of these rules would change, I did have to blow up a lot of presentations across 2 or 3 screens to be able to see them effectively. So you want to think about the format in which the viewer is going to be looking at your material and make sure it's easy for them to see it and read it. And if you have a good aesthetic, when you look at the poster, there'll be a calming effect. It'll be organized, and you'll know when you have a good aesthetic. You want to make sure you use all the space that's available to you. Don't have all the information crammed up in one corner and big blanks otherwise. If you have big spaces, then fonts can be larger, pictures can be bigger, figures can be bigger. You want to take up all that empty space. And lastly, you should really be creative and have fun with it. This is something that I kind of strive to, but I like to look at infographics and see how they effectively convey information. And in my scientific presentations, I at least try to take elements from these infographics. Notice this particular infographic that I pretty much randomly pulled off the web, but it does deal with some of the things that I research. Notice there's not a lot of text. Most of the text is pointed, it's bold, it's easy to read. They're using colors to draw your attention to this reduced 97%, reduced 66%. The numbers are color-coded. The categories are above in a particular font. You got oyster reefs, mangroves, coral reefs. And you kind of know intuitively that this is dealing with the ocean, it's dealing with ecology, and it's dealing with the value of these different marine resources. So this is just one example, but if you're looking for ways to get creative, you don't have to stay inside that box where there's a block of text followed by a figure and then another block of text. You can reimagine your poster to be the abstract. And that's what I encourage my students at the university to do, is rather than putting an abstract in their poster, which you have to do, so make sure that you put your abstract in the poster, but you can still try to make your poster be the abstract, because in the end, that's all the time that your audience usually has to view it. It goes without saying that pictures are worth 1,000 words. The more intuitive you make it, the better your science will be received. And it's a real opportunity to have some fun, I think, if you're artistic minded. So now when you get to the end of your presentation, you're generally going to answer questions. Now that didn't happen this year. but maybe for some of the people moving on to the next round, that'll happen. And here's an important rule. It's my rule number 2. We just spent the last several slides addressing rule number 1. Rule number 2 is admit when you don't know. And here's a great quote from Neil deGrasse Tyson. I couldn't have said it better, so I'm just going to read it off. There's no shame in admitting what you don't know. The only shame is pretending you know all the answers. So when you're getting questions about the research that you did, if the questions delve into an area that you don't know about, it's okay to say that either you don't understand the question or that you're not knowledgeable on that topic, but you'll be sure to follow up on that. And if you're able to do this, you're satisfying one of the key requirements for getting a PhD. I don't know if this is very well known outside of people that have earned a PhD, but generally, if you can't admit when you don't know something, you won't pass the exam that's required for you to earn your PhD. So if you can learn this lesson now, then you're one step closer to achieving in science. Okay, so those are my tips on effectively communicating your science. And now it's for those who are moving forward. Hopefully you can take some of these and incorporate them into your the next version of your presentations. For everybody else, it's time to start thinking about next year's science fair, and it's never too early. Science and discovery don't stop when the science fair is over. I encourage you to start thinking about what would you be interested in learning more about and discovering new knowledge about in a particular field of science. Maybe it's physics, maybe it's biology, maybe it's chemistry, but it's never too early to start thinking about that and start embarking upon your next project. Remember that you'll end up spending a fair amount of time just figuring out how to communicate your project, let alone completing it and coming up with a good product. I think everybody realizes how much time it takes now to put together a good scientific project. So I encourage you to think about that, and hopefully this year's science fair has inspired you as much as it's inspired me to go out and help to generate new knowledge and participate in science. I want to thank you very much for your time. Thank you for your participation in the 2021 science fair. I can't remember that big long name of it, but you can look back at the title slide. And I hope everybody has a great day.